Hello. In this video, I'm going to talk about the truth table for the conditional, for the arrow. So remember again, we're looking for tautologies, which is a sentence that is true in every situation. We're finding is a sentence a tautology or not. So remember, for the disjunction, right, we lay out a truth table. What does it look like? Well, if both disjuncts are true, then the whole disjunction is true. If the left disjunct is true and the right disjunct is false, the disjunction is true. If the left disjunct is true and the right disjunct is false, the whole disjunction is true. And if both disjuncts are false, then the whole disjunction is false. So what we want to do is, and that tells us what the disjunction means. So we're going to do the same thing in this video for the conditional. Right? There it is. That's the conditional instead of the disjunction. So we're going to have to figure out what are its truth values on these different rows. But it turns out to be a little bit complicated. So take the sentence, if I eat a cookie, I'm happy. Suppose, first of all, that I do eat a cookie and also that I'm not happy. So the antecedent is true and the consequent is false. What follows? We have a counterexample to the conditional. The antecedent is true, the consequent is false, and that means that the conditional is false. So similarly, if we have the conditional P arrow Q, and we're in a situation where the antecedent P is true, but the consequent Q is false, what follows? That means we have a counterexample to P arrow Q, and that means P arrow Q is false. So that tells us about one of the rows of the table. It tells us about the second row of the table. When box is true and circle is false, then box arrow circle is false. And that's because on that row we have a counterexample. Okay, good. But what about the other rows? In particular, we want to know, when is a conditional true? It actually turns out that it's very hard to say for natural language sentences in a general and systematic way when the conditional is true. In particular, the conditional probably is not truth functional, meaning this. The truth value of the whole thing, whether or not the whole conditional is true, you need to know more than just is the antecedent true and is the consequent true. By themselves, whether or not the antecedent and consequent are true, that's in general not enough to tell you whether or not the whole conditional is true. You need to know something about how the antecedent and the consequent are related. Does the truth of the consequent depend upon the truth of the antecedent or not? And that's not just a question of whether or not they're both true or both false or both likely to be true or what have you. You need to know about the relationship. But that we don't want to get into those complications in this course. The course is complicated enough as it is. So we want our conditional in the logical language, the arrow sign, we want that to be simple. And so we're going to make it simple, but what that's going to do is it does mean that the meaning of the arrow symbol is going to be a little different in its details than the meaning of an if-then sentence in English, or in general, a conditional sentence in natural language. So how is it going to work? Well, the conditional is false if there's a counterexample, when P is true and Q is false. We've already said that. When is it true? In any other situation. It's true, that is, if there's not a counterexample. So the conditional is false when there is a counterexample, when the antecedent is true and the consequent is false. But otherwise, we're going to say it's true. If we don't have a counterexample, it's true. So what does that mean? Well, we've decided that it's when the antecedent is true and the consequent is false, when box is true and circle is false, then the conditional is false. That's because there's a counterexample. But, okay, well, on this row, the first row where the antecedent is true and the consequent is false, that's not a counterexample row, and so the conditional is true. But what about the third row where the antecedent is false and the consequent is true? Is that a counterexample row? No. The counterexample row is a second row, and so the conditional is true on the third row in our system. And what about on the last row where the antecedent is true, where the antecedent is false and the consequent is false, where box is false and circle is false? Well, is that a counterexample? No, it doesn't show you cannot go from the antecedent to the consequent. And so again, we'll say that it's true. So what we have is this. We have the conditional is false when there's a counterexample. It's false when the antecedent is true and the consequent is false. Otherwise, for us, the conditional is true. So if the antecedent and consequent are true, like on the first row, the conditional is true. If the antecedent is false and the consequent is true, like on the third row, the conditional is true. If the antecedent and consequent are both false, There's no counterexample, and so the conditional is true. Now this is a little bit odd. The reason it seems odd is because it's simpler than our natural language conditional. You're going to want to, however, you do need to know this to use to analyze sentences that, conditional sentences using the truth table system. Now, in a sense, there's nothing complicated about this. It's just there's a truth table, but it's a little bit funny. So you're going to want to have the sheet below. You'll want to use the sheet that has all of the symbols and their truth tables on it. Use that sheet when you're doing particular problems and have this handy so that you don't forget it. And the hard ones to remember are the last two rows. It can be tricky to remember that, oh yeah, in our system, when the antecedent is false, which is the way it is on the last two rows, then the conditional is true. That just seems kind of weird. And it is kind of weird if you think of it as an English language conditional, but it's not. To summarize all this, when you have a conditional sentence, what do we know about it? It's false if the antecedent is true and the consequent is false. It's false when there's a counterexample. And it's true otherwise. So it's true if they're both true. It's true if P is false and Q is true. It's true if P is false and Q is false. Now, that's a little strange and it can be hard to remember, and so you want to use the sheet that has the definitions, and that's in the module below this video. And that sheet has the truth tables for all of the different symbols, but in particular it has the truth tables now for the conditional and the biconditional, which I'm going to talk about in another video. So please use that sheet while you're learning the truth table and really internalizing the truth table for the conditional. You'll get it. It might take a little bit of time. That's fine. Just rely on that sheet as you do the problems, and you'll be good to go.